Hey guys, this is how to calculate impulse from a force time graph. Sometimes they're called impulse graphs too, because as you know, the area underneath the graph gives you the impulse. Alright, so what we're going to try and do is estimate the area underneath a graph using grid paper. And if we can estimate that area well, then we've estimated the impulse well. Alright, so the first thing you need to do is calculate how much the area of just like one box is, and then we're gonna, after that we're gonna calculate. We're gonna see like how many of those boxes are there, and that's kind of our general way of going about this. All right. So number one, calculate how much impulse one box is worth. The impulse is the area. Remember, right? So we're basically gonna see how much area one box is worth. We're gonna do graph one on the video, and then you're going to do graph 2 on your own. Alright, so the vertical part of each box is force, alright, and it seems based on our grid lines that every 2 boxes is 20 newtons, up to 20, 40, 60, 80, 100, so one box must be 10 newtons tall. Alright, and then we could find the width of that box. It seems like every 2 grid lines is about 0.02 seconds, because we do 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, and so forth. So each one box is just 0.01 seconds. That's 100th of a second. Now, depending on the labels for force and time on the axis, the boxes could be worth different amounts of area. The force of one box, the height of it could be 20 newtons next time, possibly. We don't know. But every time we have to start by just finding the force for one box and the time, that width of the one box. All right. If you multiply those two side by side of a box, then you have the area. It's basically length times width. So F times T is the area of the box. Okay, so one box is 10 newtons times 0.01 seconds. Alright, and the area then would be 10 times 0.01 gets you 0.1 newton seconds. Oh, newtons times seconds. That's impulse. Alright, so that's how much one box is worth. Now the second step is to count the number of full boxes underneath the graph. Alright, so I'm just going to put a dot in all of the full boxes. Maybe we'll do it with a little colored pencil. I'll put a green dot in all the full boxes. There's a line through that box, so I'm not going to do that box. Here's the first full box in the bottom, second, third, fourth full box on the bottom, and the line goes through this box in the bottom row, so it's not a full box. I'm going to say this one's a full box. Line skims the edge, but it's okay. I'm going to say that one's a full box, that's a full box, that's a full box up to the third row now, and that's a full box. Alright, and it looks, if we go up to the fourth row, that the line actually goes through both of those boxes, so those aren't full boxes. So how many full boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 full boxes. Now you count the number of partial boxes. I'll do that with a orange colored pencil. If the line goes through the box, it's a partial. So those two count. Second row. Line goes through that box, line goes through that box, and it goes through that third box too. Next, line goes through that box, goes through that one, that one, that one, that one, and that one. So any box that the line passes through counts as it's partially under the curve. And that's what all those orange dots are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I just counted the number of partial boxes. That's 11. So those are located partially underneath that brown curve. All right. And the fourth step is that, so you have 9 boxes 9 full boxes. And what you want to do is each one of those boxes, well, we had calculated how much impulse each one of those full boxes counts for already. So the full boxes get multiplied by the impulse for just one box. That's how much impulse is in one box. If you have 9 of them, multiply 9 by the impulse for one box, and you get 0.9 Newton seconds of impulse provided by the full boxes. The partial boxes, we have 11 partial boxes. Alright. And what we're going to do is we're going to count all the partial boxes as halves. Just as half boxes. Some of them are larger than a half. More than half of them are located under the curve, like this one right here. More than half of it is located under the curve. Some, barely any of it is under the curve. Like this one I'm shading in right now. Barely any of it is under the curve. But we're just going to count all the partial boxes as a half a box. So we take the impulse provided by one box, halve that, and multiply it by the number of partial boxes. Alright, so 11 times 0.1 is like 1.1, and then we could times that by half, and we get 0.55 Newton seconds. So the 0.9 is the impulse provided, by all the full boxes, and the 0.55 is the impulse provided by all the partial boxes. Okay? So if we add those together, 0.9 and 0.55, then we get the total impulse, or total area underneath the curve. Alright? So 0.9 and 0.55. Alright, what is that? That is 1.45 Newton seconds. Alright, and that's the total area under the curve is 1.45. Right? So just to review, find the first step is how much impulse is provided by one box. Alright, you can multiply that number, whatever you get each time. You got to redo it for each problem. You can multiply it by the number of full boxes. Multiply it by also half the number of partial boxes, because each partial box counts as a half box. Then add those two areas together to get the total area underneath the curve. In this case, it was 1.45. Now, what I want you to do, and if this goes to homework, it goes to homework, alright, is I want you to do graph 2. You've got to start with step 1, okay? You got to say how much impulse is one box worth. Notice that the times and the forces are different, okay, on this one. Read them, do it, and bring it to class on Monday. Alright, in class on Monday I need to see that you have graph 2. What is the area provided, what is the impulse from graph 2? That's really the question. It's how to find impulse from a graph. Alright, we found impulse from graph 1. Now you have to do graph 2 for Monday, and I will check it on Monday. Okay?